Hello, my name is Tara, and this is ETS-Lindgren. Follow me as we gain knowledge from leading industry experts in audio, medical, filters, chambers, and much, much more. Welcome to Tara's Tech Talks.
Hello everyone, welcome to Tara's Tech Talk. Today we have Yibo Wang from our RF team to join us to talk about a brand new product. Yibo, welcome to our show.
Oh, thank you, Tara, for inviting me to Tara's Tech Talk.
Yeah, so we actually done a couple sessions with you in the past, right? About EMC testing standards related topics. So how about you give our audience a quick introduction of yourself, your credential background, and how long you've been working for the company?
Oh, thank you, Tara. So I'm Yibo Wang. I'm a principal RF engineer with ETS-Lindgren. This is my 7th year with ETS-Lindgren. I got my PhD degree in electromagnetics from University of Houston and Master of Science from Ohio State University.
Wow.
So my work and research mainly focus on antenna, chamber, absorber, simulation, and measurement, and antenna measurement techniques and echo reduction techniques.
Wow. So I just see this is a prototype, right, in your hand.
Yes.
This is our brand new released 3188 antenna.
Yes.
Okay, so can you give us a quick download of key specs of this antenna?
So this one is we call it 3188. So this is really a sister antenna of our 3185.
Okay.
So our 3185 is an electrical dipole antenna. So this is just like a conventional electrical dipole. When you hold the antenna, I'm pretending I'm holding an electric dipole. So the electric dipole will have an omnidirectional field distribution along the plane parallel to the ground, but the E field vector is normal to the ground.
Okay.
But for this antenna, 3188, it still has the same omnidirectional plane parallel to the ground, but the E field vector is also parallel to the ground. So we call it a magnetic loop or a loop dipole.
Okay. So what's so special about this antenna versus other antennas in general on the market?
Okay, so usually this horizontally polarized dipole, loop dipole, has very narrow band.
Okay.
So this is the first ultra wideband horizontally polarized omnidirectional antenna in this market.
Okay.
So it works from 18 gig to 40 gig.
To 40 gig. Wow, that's a very wide range, right?
Yes.
Okay. And so what sort of application will this antenna be supporting?
Oh, this antenna originally was designed for cylindrical mode filter VSWR for EMC chamber validation test above 18 gig.
Right.
So a little bit background for the cylindrical mode filter VSWR is a EMC chamber validation method above 18 gig. So it is the ANSI 63.25 working group is developing the EMC chamber validation test about 18 gig, and the cylindrical mode filter VSWR is the leading candidate of within all kinds of the methods. So to run to test the chamber performance about 18 gig, you will need to test the vertical polarization and horizontal polarization.
Okay.
So as we mentioned, for vertical polarization is pretty straightforward.
Right.
You can use an electric dipole, and you
right.
put it on the edge of the quiet zone and rotate it.
Right.
And you can test the vertical polarization. But if you want to test the horizontal polarization at such a wide frequency band from 18 to 40 gig,
right,
you can still use an electrical dipole, but you need to
tilt
rotate
it over,
here and try to rotate it around the quiet zone. But then you will have some blind spot.
Yeah.
For example, this way, you don't have any pattern, you don't have a signal from the antenna.
Right.
Or this way, right? Then you will need to run like multiple testings to compensate all the positions.
To cover all the blind spots.
Such as you need to do it this way, you have horizontal, you probably need to do it that way.
Yeah.
So then this way you can compensate that spot.
Okay.
Right? So, that's why we developed this horizontally polarized omnidirectional antenna, and you can put it mounted at edge of the quiet zone and rotate like one time, then you don't have any blind spot, right? Because it is just like the electric dipole, but only difference is the E field is parallel to the ground instead of perpendicular to the ground.
So sound like this is a much faster and efficient way to test and without any, blind spots, right?
Yes, and the working group is drafting the CC3.25 standard, and I think you will see it pretty soon.
Yeah. Okay. So, okay, if we want to summarize a few key takeaways for our audience today, to conclude the key specs of this antenna, what would you conclude?
First, so this is a horizontally polarized omnidirectional antenna.
Okay.
So it is called 3188. So it is a sister antenna of our conventional electrical dipole 3185. Second, so this is the first ultra wideband antenna from 18 to 40 gig.
Right.
Ultra wideband magnetic loop antenna in this market.
Right.
And third, this will be used in the EMC chamber validation about 18 gig according to CC3.25 standard.
Right. For a much efficient and a faster way to test.
Exactly. Yeah.
Well, thank you so much, Yibo.
Oh, thank you.
Yeah, thank you for your time. And for more information, please check on our website. Thank you.